Hey everybody, I just wanted to give you kind of an intro and a rundown for your homework number three. The first question is define the following terms: the first law of thermodynamics, the second law of thermodynamics, and C, the third part of this question, is what does it mean whenever something is thermodynamically favored or unfavored, and what does it mean with respect to that direction? These are different but very related terms. The second question is describe a reaction or any reactions with the following terms: exergonic, endergonic, spontaneous, non spontaneous, and equilibrium. Now, I want you to use these terms in a way that they make sense. So, what I mean by that, and one example that I have by that, would be something like the following: quote, the reaction between reactants X and Y is exergonic, endergonic, spontaneous reaction. Okay? Now, for your answer, I do not want you to worry about the reactants. So I said reactants X and Y. It doesn't matter what you use there. I don't want you to worry about the specific reactants or the reaction, but I want you to focus on the terms. You do not have to worry about putting all the questions or all of the terms into a single sentence. I want you to reconcile them with one another. So what I mean by that, in addition to the example that I provided, is I want you to kind of ask yourself a question of: could a reaction be simultaneously exergonic and endergonic? Could a reaction be spontaneous and non-spontaneous? And could it be at equilibrium? Or would it be most appropriate to describe a reaction as exergonic and spontaneous and at equilibrium? Or not at equilibrium. So I want you to maximize the number of those terms that you use to describe a reaction, and then use whatever terms you did not previously use to describe a different reaction. Now, again, what I'd really like to stress is I don't care about the reactants or the reaction. I want you to focus on utilization of those terms and reconciling those different terms with one another to describe a reaction. Okay. I hope that's clear, but if you have any questions, please feel free to ask me during class. Question number three, class or office hours. Question number three: what are the implications of delta H and delta S? Now, what does it mean if delta S or delta H are positive or negative? Can those values be, basically, can something be simultaneously, a reaction have simultaneously a negative delta H and a negative delta S? Or if you have a negative delta H, does that mean that your reaction will have a positive delta S or something like that? The fourth question is: how does the value of delta G relate or depend on the values of delta H and delta S? Now, question number five is repeating question number four, but put it in terms that you would use if you were describing this concept, all of this information, to a non-scientist relative. I use relative just because, generally people like to talk to their relatives. But I'm just looking for you to use, as your audience, someone who's not a scientist. So you can use metaphors, you can use analogies, or whatever you want to use to describe this term to that non-scientist relative. So, I always have a tendency to use sports as analogies. Question number six: explain everything found on pages 84 and 85 of your textbook. Now, for this, you can use a video. You simply have to provide the link, or you can type it up and put it in here. Your audience for this question is your peers, or one of your peers. So someone who's taken, a first and second level chemistry course, or so, like they've taken an organic chemistry course, and you're just trying to provide them with the context or further detail. I'm sorry, they have the context. Question number seven: draw the molecules, and maybe more prompt number seven rather than question. Draw the molecules glucose 1 phosphate and glucose 6 phosphate. Question number 8: what does phosphate transfer potential mean? And question number 9: glucose 1 phosphate, also known as G1P, and glucose 6 phosphate, also known as G6P, which you drew in question number 7, can interconvert with the help of an enzyme known as phosphoglucose isomerase, also known as PGI. Glucose 1 phosphate has a phosphate transfer potential of negative 20.9 kilojoules per mole, and glucose 6 phosphate has a phosphate transfer potential of negative 13.9 kilojoules per mole. what is the equilibrium constant for this reaction? So the interconversion from G1P to G6P. Well, I hope that helps. If you have any questions, at the end of class you can ask me, or during my office hours would be a good time to ask anything that you have. All right, thank you very much.